Hello, and thank you so much for attending this workshop today. You and I are going to begin instilling a little bit of biology into the youngest students' curriculum. And we're going to do that with a very motivating topic. We're going to be talking about puppies and dogs and some of their inherited traits. This project is funded by the BioFab Educational Workforce Development Grant, and it was done under the supervision of the University of New Hampshire. I've developed this workshop that is going to help you include all of the best practices in science education. Many of the NGSS standards are going to be addressed in your classroom. And your kids are going to be basically in command of their learning. Look over carefully the activity sheets. And activity sheets are more of a step-by-step walkthrough of the lessons that I'm providing for you. Second thing I provided is a really great collection of literature based around the topic you're studying, fiction and nonfiction. And finally, I have developed a photo file for you, and the photos will be used by you as you walk through the activities. If you have any feedback for us, please let us know. Thank you so very much. Enjoy. I began by looking at the next-gen science standards for K-2. This one, LS3-1, which is making observations to construct an evidence-based account that young plants and animals are like, but not exactly like their parents. Our unit is going to develop the very beginning concepts of life sciences with our young student. The next-gen science storylines do want you to follow specific routines, and following those routines, you are going to achieve higher level science education. This chart itself comes from Open Science Ed. Three-dimensional learning is the goal. We've all heard that. And following or walking ourselves through these routines will achieve that. So let's look at the first step, which is the anchoring phenomena. The purpose of that is simply to develop tremendous amounts of curiosity to drive the learning throughout this unit based on the common experience of a phenomenon and connections to any related phenomena students might have experienced. This is where we encourage the children to share, to develop their truths together as a group. Anchoring phenomenon always occur at the beginning of a unit, and the intent of this phenomena is to push students to go public with their thinking. It creates that opportunity for students to voice their initial ideas about whatever it is you're looking at. It identifies the areas of agreement and disagreement in the kids' ideas about mechanisms behind one or more aspect of the phenomena. Exposes to the teacher what students do and don't know about those mechanisms, and it elicits questions that the kids want to investigate. Our anchoring phenomena is going to be answering the question, how many ways can we sort dogs? It's an introductory activity. You can get the kids in groups of 2 or 3, and you just basically give each group a packet of photographs of dog that they can sort on their own. You should figure out a way to have something like a gallery walk where kids can go from table to table to see how other groups have sorted their puppies or dogs. Or one of my favorite things to do with young students is having them, once they arrive on a different group, is trying to determine, geez, how did they sort them? What was their attribute that they were looking specifically at? some results I've had from this anchoring phenomena. What is shown on the left-hand side with the white dotted background. You can look at it and see that the dogs, there's 1, 2, 3, 4, 5 dogs, in fact, sorted with short legs, and then 7 dogs sorted with long legs. Some of the observations were able to come out from prompts, like asking the students, well, what did you see? What did you notice? What was different about some of the dogs? What was the same about many of the dogs? And they can think about color or type of fur, the shape of ear. And from there, we go to development of observations, then questions, and the questions become what is known as a driving question board. It is a tool. It serves as a record of kids' curiosities about the phenomena they just saw. If you're using a driving question board in your classroom, I'd suggest taking a huge sheet of chart paper and at the top, write the unit name and then make space in the classroom for the DQB. It should be accessible to kids for additions, changes, reviews, and it should be in a space where kids can gather around it and reach any part of it. So let's look and see what it looks like in my storyline. In fact, this section I have about establishment of a DQB, driving question board. So we can make observations and state what we notice. The similarities and differences all can be recorded. Navigation is something that good teachers do pretty much in any coursework for kids. So we establish and reinforce what we have done, what we're about to do, and what we will do in the future, and what our driving purpose is in the context of the unit. And in fact, the driving purpose typically is that we're going to try to answer those questions that had been established on the driving question board. The investigative part of this unit is taking all of our scientific practices and investigating in some way to make sense of this phenomena. Students represent their thinking during any investigation routine in a bundle of different ways. They can also record their observations and their measurements, and I encourage that as much as possible. Organizing their evidence is an incredibly important part of the investigative process. Because organizing evidence, in fact, means being able to represent the evidence so that they can, on to the next one, articulate new ideas and compare them to our old models. And they're going to have to be able to revise models as time goes on. And finally, they're probably going to have to revise their driving question board. Additionally, there are tools for you to use. This is one tool that works beautifully at the end or close of every class, sort of as an exit ticket. The group decides, well, what did we just do? And you record it in the first column. And what did we see? What were our observations? And what did we figure out? Was there something we kind of figured out here? Finally, last column, what new questions might we have? I thought it'd be nice for you to see how I interpret navigation investigation cycle within my storyline. And I have developed 3 independent lessons. Third one is on the next page. The first question we want to answer with kids is, how do offspring differ from their parents? The next step of the first lesson is making some observations about different kinds of puppies. After a chance to make observations, We're looking specifically at 5 different litters. We're going to figure out what traits, what attributes are in most of the offspring. Is it the color of their fur? Is it the shape of their ear? We also want to tease out, are there any traits that appear in just 1 or 2 of the puppies? Not necessarily in all of them. All of this is going to develop to support our performance expectation, to make observations, and young animals are all alike, but not exactly like their parents. Second lesson I have laid out for you is, are we going to be able to predict and build a model of a puppy that might be born into a litter of an identified pair of adult dogs? So we're going to start off with a photo of a pair of adult dogs. Your choice. Do you want it to be pugs? Do you want it to be golden retrievers? And you ask the kids to predict what kind of traits might occur in the puppies that these 2 adult dogs have. And the kids are at that point going to create models of their offspring. This is known as the Build a Puppy activity, and it's in some of the supplemental materials that I have for you. Lesson 3 is, how can traits be used to identify puppies and match the puppies to the parent dogs? So what we're going to do here is we're going to share many parent pictures, and we'll start with a parent pair, okay? These are available for you in supplemental materials that I have provided for you. Now, the kids are going to be working with a multiple of puppy pictures. They can do this alone, so they can do a small group, or this even could be a whole class setting. But what we're going to ask is which of the puppies might match this parent pair. And as they do that, it's really important that we solicit their explanation. What is their reasoning here? So we're going to roll into the next routine. And in fact, it's called putting pieces together. Let's take a look at a slide that helps you to understand a bit more about putting pieces together. We all had questions at the beginning of this unit. We have all gone through a number of different phenomena. We've used scientific practices, but what is important sometimes, and particularly for the young student, is being able to put together what in the world we figured out. So we're looking to form consensus, constructing our explanations for things. We want to be able to synthesize things together so that students understand the concept of the day. Lesson 4 is going to accomplish that exactly. The question we want to answer with this lesson is, how do traits of specific dog breeds help them solve problems and survive? We're looking at these shared photos again of dogs and puppies. Every kid picks a picture. Each child identifies one attribute they can see, and exactly how does it help that dog? Help the dog maybe move. How does that attribute or trait help the dog find food? What problem is this trait solving? We're back at the last routine for the Next Gen Science storylines, and it is known as problematizing. Problematizing, it sort of naturally happens in your classroom when a student raises their hands and asks a question that throws a wrench in the works. In fact, that's exactly what problematizing is. So teachers can use this as a tool to throw those wrenches in the works. We present an aspect that poses a problem to the concept we have been constructing and it often means we need to maybe do some more investigation. And we can use problematizing as a very efficient assessment tool. We can assess how our students are doing with the concept when we listen to how they get through their problematizing. My culminating lesson in this storyline, I asked a question of, can we design and then draw or maybe even construct a model of a dog trait that might help some humans? So that's the work of the classroom at this time. They're going to identify that problem of a human that might be solved by adapting a trait that a dog commonly has, and drawing and building the simple model of that invention. It could be a diagram with labels, or you could let them just go ahead and use scrap materials to build their models. And they have to be ready to demonstrate how that model might help a human. Well, thank you so much for attending today's workshop. You are welcome to reach out to me with any questions you might have at scienceedconsult@gmail.com.